Okay, today we're working on section 4.7. It's called completing the square. What that means is we're going to try to build perfect square trinomials so that factoring is easy. On the first section, that's 3 through 11, all of them have been pre-set up. And so all of this on the left-hand side is going to factor perfectly, as I notice that this term here and this term here are perfect squares. That tells me that I'm hopefully just going to use the square roots. And I'll try to do that every time. So I'm going to factor the left-hand side. I've got x. Square root of 121 is 11. This tells me the signs are the same. And I come over here to tell me that they're both negative. So negative, negative. And that'll work out because I'll get negative 11, negative 11. That gives me the negative 22. The important thing is that because these are identical, I can rewrite it as x minus 11 quantity squared equal to 13. And the perfect part about that is that I can now get rid of this exponent by just taking the square root of both sides. Make sure you take your accessories. So that would leave me with x minus 11, because the square and the square root cancel, equals plus or minus root 13. All I have left to do now is to add 11 to both sides. When I add 11 to something that's got that plus and minus in front of it, I'd like to keep my answer as 11 plus or minus root 13. That's my answer. That's it. Now, be careful though, if this was 5, for instance, this is a side point. This is not part of the actual problem. But sometimes you'll come across stuff like 11 plus or minus 5, because the square root will be perfect. So square root of 25 is 5, so that would give me something like this. I would need to add and subtract to get the two values. 11 plus 5 is 16. 11 minus 5 is 6. So that's how I would do something more like that, okay? Again, not part of this specific problem, but it might still be useful. 21, we go into the second section of the assignment, and they're asking us for two things. First, they ask us if you could put any number here, what would it be? Okay, so you get to pick the number, what would you put there? Well, in order for this to be a perfect square trinomial, I need to start with the coefficient here. This is a 1. So, my c value is always that number, 1, divided by 2, and then I square the result. So I'm taking half of this number, so 1 over 2, and then I square it. When I square 1/2, I'm going to square the top and square the bottom. That ends up being 1 over 4. So my c value is 1/4. Now, I didn't take the negative, but even if I had, negative 1 squared is 1, so either way gives me the same answer. Then they're asking, if you put that into the equation, 1x plus 1 over 4, what would the parentheses look like when you factored it out? You know, you'd have x and x. The signs are the same and subtraction, so minus minus. And then you take 1/4 and you want the square root. Well, you could do the square root of 1 divided by the square root of 4. That would give you 1/2. Or you could just take half of the middle. Half of 1 is 1/2. Either way will get you the same thing. And so the answer that we're looking for is x minus 1/2 quantity squared. Most of the problems won't give you these fractions, which I know are a little bit harder to deal with. But, you know, the process is the same. Half of the middle squared. Okay? This is our last number. The last one we're going to look at together, and then hopefully you guys will have enough to get going, is number 30. When we look at number 30, the first thing I notice is this right here. I don't like this 4 here. And if I can, I'd like to get rid of it. So I'm going to divide everything in the problem, both sides, by 4. That'll leave me with x squared minus 10x minus 3 equals 0. Now I need to look right there and ask the question, is that negative 3 a perfect square? No, it's not. So let's go ahead and move it to the other side. So I'm going to add 3 to get it out of my way, because I need a perfect square right there. So x squared minus 10x plus something. Right now it's 0, but I know I want to put something else there. Is equal to 3 plus that same item. Whatever I'm going to insert into the equation on the left, I need to also do it on the right. And so I have to start with finding that c value. I know that in this case, c will be 10 over 2, and then I square it. 10 divided by 2 is 5, and when I square 5, I get 25. So I'm going to add a 25 here and a 25 here. Now I can start to simplify. This parentheses, I want to jump straight to the squared version. I would have x, because that's the square root of x squared. The square root of 25 is 5. Signs are the same and negative. And over here, you get 28. And so, right here, when we look at this, now we need to take care of this square. So we'll start by taking the square root of both sides. When we do, we need our accessories. So the square and the square root cancel. I get x minus 5 equals plus or minus, well, 28, the root of 28 is composed of the root of 4 and the root of 7. I know the root of 4 is 2, so this is 2 root 7. I've just done some simplifying off to the side. Last step is to move this 5. So I'm going to add 5 to both sides. When I do that, I always want this 5 to go in front of the plus or minus because it's not part of the root. So x equals 5 plus or minus 2 root 7. There's no way for me to find the answer there because I can't combine the root and the non-root number 5 here. So, oh, that wasn't good. Let me change that, put that back, and you guys are good to go. Those are the 3 types of problems. Remember, the first type is about factor and solve. The second type, you're finding the c value, and then you're trying to set the factor up, that squared parenthesis. And the third one, you have to insert that perfect c value into both sides of the equation, factor and solve. So once you've put this 25 in here, the problem became just like number 3 through 11. So that should be hopefully enough to get you going and answer a few questions. Talk to me on Monday with what you don't know.